Okay, so from bottom to top, atmosphere is divided into various layers. So what are these various layers? Let us understand. So basic atmospheric structure, if you see, so 99% of the total mass of all the gases is confined only up to 32 kilometers. So atmosphere is denser only up to 32 kilometers. After that, atmosphere starts getting rarefied and rarefied and rarefied. Okay. So at the top, let us say 400 kilometer up, you have an atmosphere. But gases are very rare that they are literally in the monoatomic format. Okay. So here you will see molecule of oxygen you will find on the surface. But 400 kilometers above, you will find the oxygen atom separately. Getting it? So they are almost in the monoatomic form at certain height. So gases in the atmosphere, if you see atmosphere as a gases, water vapor, dust particle, oxygen is almost absent after 120 kilometers. So oxygen is absent after 120 kilometers. Okay. So here carbon dioxide and water vapor, they are present only up to 90 kilometers. Okay. So CO2 and water vapor, they are present only up to 90 kilometers. So these facts are very important from prelims point of view. One of the options will be there in your exam like this. So you must know this. Okay, it is given in your notes as well. Okay. Now composition of the atmosphere is also one of the very important thing. Composition of the atmosphere, 78% is nitrogen, 21% is a oxygen. After that you have argon, and after that you have carbon dioxide. Okay, so nitrogen, oxygen, argon, and then you have a carbon dioxide. These are the four dominant gases in the atmosphere, and the lowest amount of gas is a hydrogen. Okay, so now some of the gases present in the atmosphere can retain the long wave radiations emitted by the earth. Okay, they are transparent to the short wave solar radiations, but they can absorb the long wave radiations emitted by the earth. So they are called as a greenhouse gases. These greenhouse gases keep our atmosphere warm. Okay, so you can see this how this is a layer of this is a layer of greenhouse gases over here. So they are transparent to the sun rays. Okay, but the red color rays that you are seeing that are emitted by the earth, they are long wave earth radiation. They are absorbing that radiation. Because of that, our atmosphere remains warm. Whatever warmness that we feel, that is because of these greenhouse gases. Okay, so these are some important greenhouse gases. Water vapor also act as a greenhouse gases. Okay, so let us understand the overall structure of the atmosphere. So from bottom to top, there are various layers of the atmosphere. So these layers have been classified according to the height and change in the temperature. Okay, so in some layers, as you move upward, temperature is decreasing. In some layers, as you are moving upward, temperature is increasing. Okay, so based upon the temperature of the layer and particular characteristics present of particular gases, these layers are classified accordingly. So let us understand these layers and their importance. Okay, so first layer is a troposphere, then you have a stratosphere, then you have a mesosphere, and after that you have a thermosphere. Okay, here thermosphere is actually, it needs to be coming as a fourth layer. Okay, so by mistake it is in front of mesosphere. Okay, so fourth layer is a thermosphere and fifth layer is a exosphere. Okay, so let us understand this layer one by one. So here you can see this is the x-axis, which is mentioning the temperature, and y-axis is mentioning the height. Now, as you see, first layer is a troposphere, or in troposphere, as you are moving upward, temperature is decreasing. This is called as a lapse rate. Okay, so lapse rate in the troposphere, as you are moving upward, temperature is decreasing. Then comes a layer of transition called as a tropopause. At tropopause, temperature is constant. After tropopause, as you are moving upward, temperature increases. Why temperature increases? Because in the stratosphere, you have a ozone. So ozone's characteristic is it can absorb the solar radiation directly. Okay, so because it is directly absorbing the shortwave solar radiation, that is why it is keeping that layer warmer. Okay, after that comes a stratopause, then comes a mesosphere. In mesosphere, as you are moving upward, temperature is again decreasing. Okay, then comes a mesopause, then again come a thermosphere. In thermosphere, as you are moving upward, temperature is again increasing. Why it is increasing? Because here the gases are present in the monatomic form. Also, there are free electrons present in this layer. So they absorb certain amount of sunlight. That's why temperature increases as we are moving upward in the thermosphere. So after that you have an exosphere. So function wise, if we see all these layers, this diagram summarizes the function of all the layers. Okay. So first troposphere, if we see all the atmospheric phenomena like lighting is there and so many things are there, it is happening in the troposphere. Stratosphere, jet planes are always flying in the stratosphere because there is no atmospheric phenomena happening. So this is a very stable layer. So aeroplanes fly through the stratosphere. After that, mesosphere. Whatever meteorites that enter into the Earth's atmosphere, almost all of them get burned in the mesosphere. They don't cross mesosphere. Getting it? And after that, you have a ionosphere or thermosphere, and then you have a exosphere. So ionosphere and thermosphere is very important for satellite communication. Okay. So we will understand them one by one. So first layer is a troposphere. So here you can see this is a layer on the top of the earth. So first layer on the top of the earth, it is a troposphere. The thickness of the troposphere, if we see, so thickness of the troposphere is more on the equator compared to on the pole. Okay. So you can see over here the thickness of the troposphere is more on the equator compared to thickness on the pole. So what is the reason for that? So the reason is on the equator we get more sunlight. So because of that, air is heated because of this heating, convectional current rises very high over here. Getting it? So the height at which convectional current rises on the equator is higher compared to poles. So that is why the thickness of the troposphere is greater on the equator. Okay. Similarly, on the poles there is an absence of solar radiation. Okay. So that's why there is no heating and almost absence of convectional current. So thickness of the troposphere is lesser on the poles. Also, if we see gravitation wise, pole is little bit closer to the center of the earth compared to equator. Earth is little bit bulged on the equator. So distance from the center is little higher on the equator. So gravity is also little lesser on the equator compared to poles. So that is why poles have a thinner layer of troposphere compared to equator. Getting it? Okay. So average height is 13 kilometers. Equator has up to 16 to 18 kilometer thickness and pole have a 8 kilometer thickness. Getting it? Okay. So all the weather phenomena, whether it is a cloud, whether it is a storm, whether it is a snowfall, all is happening in the troposphere. Understood? Okay. So now next layer is a stratosphere. Okay, before going to stratosphere, the lapse rate in the troposphere, as we are moving upwards, temperature is decreasing. How much it is decreased? 1 degree Celsius for 165 meter. Okay, how much? 1 degree Celsius for 165 meters. This is a lapse rate. Okay, so for example, in UPSC question can be asked on the sea level, the temperature at the Chennai at the sea level is 35 degrees Celsius. So what will be the temperature at the height of 8,500 meters on the top of the Mount Everest? Getting it? So here for that you must know the lapse rate. So as you know that if at the height of 0 the temperature is 35 degrees Celsius, so 9,500 meters up, so you have to divide it by 165 meters and then the answer will come how much temperature will be there at the top of the Mount Everest. Okay. So these types of questions can be asked in the UPSC exam. Okay. These are the application based questions. Now understood this part? Now next is a stratosphere. Stratosphere is the next layer of that of troposphere. Here you have oxygen present as one of the agents in this region. So here you have ozone, presence of ozone. So the quality of the ozone is that Ozone absorbs shortwave radiations of the sun, so it saves the life on the earth from the harmful solar radiation. Okay, so if ozone is not there, we will have skin burning and skin cancer will be more. Okay, plants won't be able to survive, animals won't be able to survive. Okay, so the stratosphere contains ozone, so that's why once you enter into stratosphere, as you move upward, temperature decreases, sorry, temperature increases. Okay, so lapse rate is different in the stratosphere compared to troposphere. So you can see this, the reaction, how ozone is formed. Ozone is nothing but a 3 atoms of oxygen together. Okay, so in the presence of sunlight, what happens, this oxygen molecule breaks up, 2 oxygen atoms get separated, and this highly reactive oxygen atom get attach itself to the one of the free oxygen molecule, and O3 is formed. So this reaction is continuously going on. Breaking of oxygen molecule, breaking of ozone molecule, and formation of free oxygen atom. This reaction is continuously going on in this layer. And formation of the ozone layer is continuously going on in this layer. Getting it? So this is very, very important layer. So jet streams are also flying in this region because there is absence of atmospheric phenomena. Okay. So all these things are absent, like rainfall and all these things are absent over here. So here jets, passenger don't feel any disturbance. They don't feel any fearful while traveling by the plane. So that's why jets are traveling through the stratosphere. Okay. Now next is a mesosphere. After stratosphere is a mesosphere. In mesosphere, as you are moving upward, temperature is decreasing. Getting it? So mesosphere is one of the very important layer. So burning of the meteors happen in the mesosphere, that we have seen. Okay. So mesosphere is very, very important. Now next is the ionosphere. We have seen that ionosphere is very important for the purpose of radio communication. Ionosphere, the height is from 8, can see, after 80 kilometers to 400 kilometers, you have this ionosphere. So this ionosphere, as name suggests, contains charged particles. Okay, so these charged particles, okay, these charge, they can be electrons. Generally, gases are present in the monoatomic form. So it is a soup of monoatomic form gases and free electrons. So we are calling it as a ionosphere. So what happens over here? So these ions, they reflect back the radio waves. Long wave radio waves are being reflected back by the ion and free electrons. Getting it? Because of that, mobile communication, satellite communication is possible in this layer. Getting it? But shortwave radiations are not generally reflected back. So you can, that's why you can do the communication with another planet. Getting it? Okay. But within the planet, if you want to do the communication, then this layer is very important because it is reflecting back the long wave solar, long wave, any long wave radiation. Getting it? Understood this? Okay. Now, these are the different importance of different layers. Now there is one phenomena called as aurora. This is very important phenomena, aurora. So aurora is formed, and this ionosphere is also very involved in formation of the aurora. Okay. Also, magnetic properties of the earth are involved in the formation of the aurora. So what is aurora? Aurora means what? What happens over here? Charged particles from the sun are continuously hitting the earth. Okay. So these charged particles are kept away by the magnetospheres of the earth. So we have a magnetosphere, it keeps this charged particle away from the earth. Okay. So near poles, what happened? This pole, you know, height of the atmosphere is very less. Okay. So near pole, what happens? These charged particles, ejected charged particles by the sun, okay, they interact with the earth's magnetic field and the gases which are there in the monatomic form over there. Okay. So when they interact with the gases, Gases gain the energy from this charged particle. When they gain the energy, electrons in the shells of this atom, they jump from the lower orbit to the higher orbits. Okay. So when electrons, they jump from lower orbit to higher orbit, after some time they lose the energy and again they come from higher orbit back to their original orbit. So in this process, whatever energy they lose, that energy is emitted in the form of various colors of light. Okay. So these various colors of light is seen in the form of aurora. So this aurora is called as aurora borealis in the northern hemisphere and aurora australis in the southern hemisphere. Understood? So this is a phenomena of aurora formation. Okay.